Welcome to Oceanic and Polar Experts. In this episode, I will talk about two kinds of circulations of ocean currents, wind-driven and thermohaline. Surface ocean currents, accounting for only 8% of all ocean water, are driven by wind currents, primarily confined to the upper 400 meters. These currents are distinct from deeper waters due to differences in temperature and salinity, which affect water density and define various oceanic regions. In this wind-driven circulation, there is an important effect called the Coriolis effect. What is the Coriolis effect? A definition provided by National Geographic. The Coriolis effect describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances around Earth. As we know that the Earth is a slightly flattened sphere, the distance traveled by air circulating the Earth at high latitudes is less than the distance traveled by air at lower latitudes, e.g., near the equator. Therefore, for one rotation made by the Earth in 24 hours, the speed of the air near the equator is almost 1,600 kilometers per hour, a lot larger than the speed of the air close to the poles, which is only 0.00008 kilometers per hour. If the air near the equator travels up to higher latitude regions, due to inertia, it maintains the speed while the higher latitude regions are traveling slower. As a result, it is ahead of the air in these regions. On the contrary, if the air closer to the North Pole travels to equator, it is slower relative to the equatorial regions and falls behind. This means that the air deflects, and anti-clockwise air currents are formed. Different from the northern hemisphere, the southern hemisphere forms clockwise air currents, as the air from above, i.e. regions with lower latitudes, is traveling faster ahead, whereas the air from below, i.e. regions with higher latitudes, is traveling slower. Surface ocean currents are mainly driven by the wind moving over the water and the Coriolis force, the invisible force used in mathematics that appears to deflect the wind, affects the direction of these currents in cyclones. Due to the Coriolis effect, ocean currents deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Thermohaline circulation is also often called the conveyor belt. An essential component of the Earth's thermohaline circulation is deep currents. Driven by density and temperature gradients, these deep underwater currents, also called submarine rivers, flow far beneath the ocean's surface and are not immediately detectable. Upwelling and downwelling are names for areas where significant vertical movements of deep ocean currents are found. The term thermohaline circulation describes the large-scale movement of ocean water driven by global density gradients, which are created by variations in surface heat and freshwater fluxes. The term thermohaline itself combines thermal, which means temperature, and haline, which means salt content, the two factors that together determine seawater density. For example, wind-driven surface currents, such as the Gulf Stream, travel poleward from the equatorial Atlantic Ocean, cooling as they move. As these waters cool, they become denser and eventually sink at high latitudes, forming what is known as North Atlantic deep water. This dense water then flows into oceanic basins, with much of it upwelling in the Southern Ocean, while the oldest waters, which can take around 1,000 years to complete the journey, upwell in the North Pacific. This circulation facilitates extensive mixing between ocean basins, reducing differences between them and integrating the Earth's oceans into a global system. As these water masses travel, they transport energy in the form of heat and matter around the globe. This movement has a significant impact on the Earth's climate, as it distributes heat and influences weather patterns. Thank you for listening to Oceanic and Polar Experts. See you next time.